the discovery of something new is something absolutely amazing. So I tested on myself when we discovered the Higgs. It's a moment you will never forget.
Welcome to Chelonia Podcast, a podcast about the use of scientific discovery of technology applications. We provide the best information on projects participated by Chelonia and many more. My name is Gabriella Bernardi. I'm a science journalist, and in today's episode we talk about physics and experimental research with Professor Chiara Mariotti from CERN. Nice to meet you, and would you please briefly introduce yourself and talk about your education and work experience?
Thank you, Gabriella, for this nice opportunity. So I am like you, I'm from the Torino region. So I did my high school in a small village in the south of Torino, where my physics teacher was a very fascinating person who really passed me this love for physics. So then I studied indeed physics at the University of Torino, where I got my degree working for an experiment at Fermi Lab. So my PhD thesis, master thesis was at Fermi Lab. Then I also got a PhD scholarship in Torino, but I moved to work in an experiment at CERN. So that was called the New Muon collaboration. So I did all my PhD essentially based at CERN. And when it finished, I found a postdoc instead in Rome to work for another experiment at CERN. It was the Delphi experiment at the Lab Collider. So it was a collider that was active in the last 12 years of the 12th century. So from 1989 to 2000. And during that time, I also got a position at CERN for 6 years. So I've been really employed by CERN for 6 years. And then when the contract finished, I went back to Torino. And since then, I work as a researcher at INFN in Torino, but I'm based at CERN. So most of my time I'm at CERN.
So, Professor, how did you end up in your role at CERN?
Yeah, so exactly during my postdoc in Rome, and also during my first year as an INFN researcher, I was working for the Delphi collaboration at the Lab Collider. And I was working both for the construction of a new detector that at the time it was end up to be the biggest silicon detector of the time. And I was also working for the identification of the beauty quark. So as you know, there are 6 quarks. One of them is called the beauty. And that my work at the time was really to find the best way to identify events that contain the beauty quark. So the responsible of the Italian team in Delphi asked me if I could stay at CERN 100% to be more efficient in my work. Remember that at that time, that was 1990, there was not the World Wide Web, so there was not this possibility to work from far away from home, etc. So when you had to work with somebody, you had to meet in person. And the flight was expensive, the phone was expensive. So it was important for my work to be as efficient as possible that I would come at CERN and work with the CERN team. So I moved to CERN. And then just maybe 1 or 2 years after, the spokesperson of the experiment asked me to apply for a CERN position. And then I did it. And then during that 6 year of position at CERN, it was a very exciting period, and I got very important responsibility. So I got to be the physics coordinator of the Delphi experiment. And then in the meantime, I also met my husband, that is also an employee, a CERN employee. So when my contract was over, I got back to Italy, to CERN, to Torino. I anyway had big responsibility at CERN, and then later on also my family at CERN. So my work kept to be essentially concentrated at CERN. And then again, I got another contract at CERN during the time of the Higgs discovery, because I was responsible of groups that were really that had the responsibility for the search for the Higgs. So at that time as well, I was at CERN 100% with a contract from CERN.
Very interesting. And now, are there some aspect of your career or research you would like to talk about?
Yeah, I think, our job as physicists, especially experimental physicists, it varies a lot. You can do many different things. You can work on the detector, you can develop a new detector technique, you can work on data analysis, or software or computing. So you are quite free to choose what you like most. So this for me is very nice, because it allows you to do many different things and to really do what you like most. And what I like most is really to analyze the data. So really to try and to understand how the data behave, what they hide inside them. And that was what I did most of my time, and I really had a big passion for it, and was my main, really my passion. But recently, especially after the Higgs discovery, when I must admit I had a very difficult time after the Higgs discovery, because it was, I was looking for this particle for 20 years. Finally, you find it, and you find yourself without a strong motivation behind. But again, so after the Higgs discovery, I have been called to serve in many boards that select young professor or student, or in boards that give advice about the line of research for the laboratory. And it is less creative, because of course it's more of it's a work of a board. You look at the work of other people. It's not you are creating something. But I started to like it a lot, because essentially you are given the responsibility to, for example, to pick up the right guy that then will shape the future of our field. And I must also say that this job is not so easy for me, because it keeps me awake at night, because you are deciding the life of a person, what will be his or life, if he or she will take the job or not. But it's nice, because you met many interesting people and many new ideas. So I must say the part of the job, to answer again your question, the part of the job that I like is really this variety of activities that you can get involved.
Now, are the scientific progress that you are thrilled with, and what's your biggest challenge right now?
Yeah, so of course, the discovery of something new is something absolutely amazing. So I tested on myself when we discovered the Higgs. It's a moment you will never forget. But I also like the fact that we can in different, not only in my field, but also in astrophysics or in other branch of physics, you can reach the precision, certain precision that are amazing. So you arrive at, you have the capability to measure incredibly small quantities. Now, instead of talking about what we measure, okay, for example, we measure lifetime that are one picosecond, or I can make you an example of the gravitational wave, that you essentially measure a variation that is about 1,000 of the size of the proton. So can you imagine a proton, and then you divide by 1,000, and then you measure a variation of that distance. Or recently I met Michel Mayor, the Nobel Prize in Physics 2019, and also what he did. If you think it's amazing, between billions of little spots in the sky, bright spot in the sky, he managed to discover the first planet.
Now we can also imagine what keep you awake at night, or what motivates you to get up in the morning.
Okay, so what kept me really awake for almost 1 week was the discovery of the Higgs. So as I told you, after it was about 17 years, I was working to search for the Higgs, and then suddenly you find it, and then you cannot sleep. Simply, you can.
Imagine.
It was 1 week that I could not sleep. It was so much adrenaline that you could not close your eyes. And then worst of all, we had to keep it secret, because the announcement should have been made 2 weeks later in an official way at CERN, etc. So you had to go around at CERN and be serious, and you could not smile in the corridor. This was really hard. But then, for example, what kept less romantic, what kept me awake, is when I'm in this board and I have to decide about these young people and about their life, this really keep me awake, because I always ask myself if I'm doing the right, if I'm taking the right decision and giving the right opinion. What motivates me to get up in the morning is really the challenge of the thrill of the challenges, the thrill to solve a problem, even little things. So this is what I liked from the beginning when I was at high school, that I liked very much to solve math problem. And this is what I also like now, really solve little mysteries and little problems.
So, Professor, now you can talk about what was your biggest success and failure in your career.
So, from the physics point of view, well, there is no story. It was the Higgs discovery in 2012. It was really an amazing discovery. It was the discovery of the last a piece of puzzle of the standard model, that is the model that described the particle, the elementary particle. So this was really, as I said, I couldn't sleep for 1 week. And then it put me in a kind of really baby blues afterward, because then you need to find again the motivation to restart working. But this was really my biggest success from physics point of view. Career point of view, I think the biggest moment for me when I got the staff position at CERN, really that was something amazing, because my work was recognized and I was super happy. And also when it was 2018, so 3 years ago, I got the Emmy Noether distinction from the European Physical Society. this also was an amazing moment because it recognized what all the work I did for the Higgs discovery and for the formation of the young generation of physicists. And that was amazing. So you are so happy, you smile for months. And big failure, I don't know if I would call it failure. So big failure, fortunately, none. Difficult time, yes. And I think the difficult time for me were really, I'm sorry to say it, but it were really due to some bad situation that we have in Italy when your colleague, they don't recognize what you do and they ignore you and they somehow try to neglect what you do. And that's why I said the EPS prize was really something, was a real joy.
So, Professor, you remember Emmy Noether Prize. Do you feel that the public perspective of women in science has changed over the course of your career? And what do you wish you had known when you were first starting out?
So yes, indeed. From my PhD time up to now, the perspective of women in science, it changed a lot. If not for other reasons, simply for the fact that now we are many more. So we are 20% of more. For example, at CERN, we are about 22% of women at CERN. And when I did my PhD, so it was more than 30 years ago, we were not even 10%. So there is a change of mentality because men are getting used that there are women around them that work as well as them, if not better. So yes, so it changed and it keeps changing because now we talk a lot about it, and thanks also for this prize given to women. I think, maybe it's not fair, but it's good it's important for us because it underlines that we are an active part of the community. What would the second part of the question, what I would have wished to know? Maybe nothing in particular, because if I knew that it was hard, the life as a woman in physics, I don't think I would have done something different. And I think it's important that you are not affected by this and you keep doing what you want to do. And you simply have to insist and never stop. And for that, I must say, my mother, when I was young, when I was at school, during high school, was always telling me, if you want, you can. And I think that's great. And this is true, because it means if you want and you keep and you insist, you manage.
Great mother. Yes. Now, Professor, we are in 2021, and which challenges do you feel there are for the next generation of scientists?
Yeah, I think that it's very hard now to look for a direction, because we know that the standard model is working very well. We found the Higgs, that was the last missing piece of the standard model. But we also know that this does not explain everything. For example, the dark matter. So I think the real challenge now is to keep going on, to keep measuring quantities with very high precision, so with the highest precision possible, and keep looking for deviation from the standard model. And this is very challenging because it's, of course, it needs a lot of work, and it's a lot of time and calculation and dedication. But this, I think, it is the big challenge now. And indeed, the LHC will go on for another 17, 20 years. So this is what we will have to do now. Maybe after all this infinite number of precision measurement, we will understand that we have to rewrite something, that the standard model is not the model, but indeed we miss something, and whenever we will understood what we are missing, we will design a new picture. One other big challenge to me is the experiment. So this experiment we are working now at LHC are really very, very big. And the way of working is completely different with the way we were working in previous experiment. My PhD thesis, we were 50 people. Maybe for the young people is okay. For me, it's hard to get used to, but maybe for them it's okay. But maybe this is not the way, just to get bigger, to go to high energy and get bigger, and we have to simply think of a different way to understand our world. And I think this is an even bigger challenge.
Yeah. Professor Mariotti, if you could go back or forward in the time, what would you like to know or discover?
So, okay, I'm very biased because the Higgs for sure was my first priority. I also think they would have been nice to discover the antimatter. Can you imagine to discover that there is the antimatter and see it for the first time?
Yeah.
I think that would have been amazing. And to go forward in time, then I will maybe move to astrophysics, and I think life on another planet or travel in time, as Hawking always said, it will be possible.
Fantastic. Last curiosity, if you weren't in your home field, what other career would you pursue?
This is a very difficult question because in my life, let's say like this, it really depends on the time. I would have done different things in different period of time. So, for example, when I finished the high school, I was even thinking of doing architecture. That was one of my other dreams. And I was also studying music. So I was also thinking of going into music. Then, for example, I restarted music recently. I got my degree in music. So I'm now playing in an orchestra, and I even have 6 months experience teaching in a school. So yeah. That was also fun. And then, maybe some other period I said, why I didn't do astrophysics? It's so fascinating. And you look the infinitely large instead of the infinitely small. And then I must say all the time, what I also like is anyway to be a teacher. This is, I think, a very important part of our life. So a good teacher changes your life, and I think it's important to try to be a good teacher whenever it's possible. And this, I think, it's something that I could have possibly have done instead.
Absolutely. Thank you so much, Professor Mariotti, for joining us today at this podcast, and thank you, our listeners. If you have any questions about today's show, you can get in touch on Twitter, and feel free to subscribe to Chelonia.Swiss website and be part of the community. In the meantime, stay tuned for our next interview. Bye-bye.
Bye-bye.